The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example: finding temperature change when the standard free energy is at equilibrium. Find the temperature change for water when the standard free energy change is at equilibrium and the standard enthalpy is given to us at 6.01 kilojoules per mole and the standard entropy change is given to us as 0.0220 kilojoules per Kelvin mole. Wonderful. Now, let's begin here by writing down our standard free energy change equation. That was just the following, if we recall, right? There we are. And now they're telling us that the standard free energy change right here is at equilibrium. And recall, when it's at equilibrium, it's going to be equivalent to 0. Thus, what is it? What we're looking for now? We're looking for temperature, and we can just go ahead and isolate for temperature. Let's go ahead and do that now. And then once we go ahead and we isolate for temperature, our equation just becomes as follows. Now let's go ahead and just plug in our values. It's telling us here that the standard enthalpy change is going to be 6.01 kilojoules per mole, right? Now, what is the standard entropy change? Well, that's given to us as well, right? At just 0.0220 kilojoules per Kelvin mole. Wonderful. Now, once we go ahead and we equate this, let me just make this a slight bit neater for us. Once we go ahead and we equate this, we find that the temperature is going to be roughly 273.18 kelvins, which is roughly 0 degrees Celsius. And there we are. Now, at 0 degrees Celsius, that should make sense because that's the melting point for water. Now, so what that tells us then is that when the standard free energy changes at 0, that water and ice are at equilibrium at 0 degrees Celsius. Furthermore, when the standard free energy change is at 0, or another way that we can say the exact same thing is saying that when we have a change going from spontaneous to non-spontaneous, right, we could use the following equation here, right, to find the temperature at when that change occurs, which was actually the main point of this slide. And if you think about it, it's quite remarkable that we can find we can pinpoint it right down to the exact point. Wonderful. I hope that was helpful. Let's now continue to our next slide. Great. Let's now shift our attention towards standard free energies of formation. Let's begin here like we always do with a definition. Standard free energy of formation is the free energy change for the formation of a mole of a substance in its standard state from its elements, also in their standard states. Now, this equation here, it allows us to actually find the standard free energy change from the standard free energies of formation as it shows here. Furthermore, just as for the standard enthalpy formations, for elements that were in their normal states at 25 degrees Celsius was 0, it's the same for our standard free energies of formations. And we'll see an example of that on the next slide. All right, great. Let's actually just get right into it, and we'll just jump right in here now. Find the standard free energy change for the following reaction from the given standard free energies of formation. Wonderful. So here are our standard free energies of formation. You'll typically be given these in a table, and when you are given them in a table, just be cognizant of their states as such. It's a very common mistake that I see. So once again, just be cognizant of the states of the standard free energies of formation that you will be extracting from the tables. Now, getting back to our problem, we always commence by seeing if our equation is balanced. Is our equation balanced here? No, it's not. If you like, take a moment now, pause the video, and try balancing yourself. But for the rest of us, let's continue here. And I'm just going to go ahead and balance this equation equation for us. So there's a 3 there and a 3 there as well. Wonderful. Now the next thing that we can do is we can go ahead and write down the equation that we had just learned, right, on our previous slide to find the standard free energy change, right, from the standard free energies of formation as such. Great. There we are. And then that was from the products minus, that says products there, minus the sum there of the standard free energy. So formation for the reactants. Great. Let's actually go ahead now and expand on our equation here a little. I'll shift it towards the right just so we have a little bit more room as we work through this. Looking first at our products, we have 2 moles of carbon dioxide here, right? So yeah, wonderful. We also have 3 moles of H2O, and let me just, I think I forgot to close that bracket there. Yeah, 3 moles of our H2O gas here. And there we go. Minus, we have a mole here of ethanol, C2H5OH, liquid, plus we have 3 moles of our oxygen. Now, we just stated in the previous slide that when we have elements in their normal states at 25 degrees Celsius, they're going to be 0. Here's one right here. Thus, we know that our value for oxygen here, that will be 0. Wonderful. For the rest of them, and that's why we don't see it written over here with the rest of our values here. Wonderful. Let's actually go ahead now and we just fill in our values. And in doing so, for carbon dioxide, the value given to us is negative 394.4 kilojoules per mole, right? We're also given the value here for our H2O gas here as well. That's just going to be negative 228.6 kilojoules per mole. Wonderful. And lastly, just our ethanol, which is going to be negative 174.9 kilojoules per mole. And there we are. And for oxygen, it was just going to be 0, right? Thus, when we go ahead and we calculate this, we find that the standard free energy change is going to be negative 1,300. Let me just erase that. I believe it's going to be negative 1,300 kilojoules. There we are. Wonderful. So that there is how we would find the standard free energy change from the standard free energies of formation. Wonderful. Let's proceed now to our next slide. Now we're going to be taking a look at free energy change for non-standard state conditions.